The concept ether hypothesis. For the propagation of waves, a material medium is necessary. It was considered that light propagates through hypothetical medium, ether, while sound waves propagate through air. Ether is supposed to occupy all space. In Michelson's Morley experiment, the time taken by a beam of light to travel along the direction of the earth is greater than that to travel distance opposite to the direction of the motion of the earth. The presence of ether could not be detected. In order to have the actual study of this, the time taken by a beam of light to travel along the direction of the earth is greater than the time taken by the beam of light to travel the distance opposite to the direction of the motion of the earth is the ether hypothesis. Now we can see Michelson's Morley experiment. A schematic diagram of the setup of Michelson's Morley experiment. This upward arrow is shown as velocity direction in luminiferous ether band. Now it is the actual setup. The monochromatic light source is here. From that, a single ray is made incident on this beam splitter, which is put inclined at an angle of 45 degree. From this, the beam is single incident ray is split into two rays. One is partially reflected ray along the direction C, mirror M1, and another one is partially refracted ray along the direction AB towards the mirror M2. Means for a single incident ray, it is a single partially refracted ray towards mirror M2 and it is the ray towards the mirror M1. And when the ray C on reflection through this mirror M1 goes downwards towards A, the reflected ray from mirror M2 goes in the backward direction along the direction BA. Both the rays coming downward from C, that is from mirror M1, coming backward from B, that is mirror M2, both are detected in this detector, and there is a condition of minimization of path difference in order to have either minimum of interference or maximum of interference. The actual path traveled by the rays from light source to A to mirror M1, A to mirror B, again B to A, mirror M1 to A, and so on. It is shown here. The total distance traveled by that array from A1 to A3 is equal to D. It is shown in this small picture. The apparatus is moving in either ether wind at speed v. Light travels from the source to the beam splits, which splits the light beam into one of the beams travel to mirror M1 and other to mirror M2 before returning to and reuniting at the point A, whereafter the reunited beam travels to the detector. That is the beam coming from M1 in the downward direction, beam coming from M2 in the backward direction. Both these beams are reunited to the detector. A rotation of the whole apparatus should manifest itself as shift in the fringes if the luminiferous ether exists. Opposite is a schematic diagram showing the path of the light beam taken by the beam traveling to mirror M2. Michelson interferometer permits observation of the interference between two beams of light traveling paths of about same length. The beam is split by the half silvered mirror and the two beams are reflected and recombined. They will interfere constructively if their paths are of equal length or if they differ by an integral number of wavelengths. The question is arising here whether the two rays coming towards detector are constructively interfered or destructively interfered. The interference will be destructive if the paths differ by half integral number of wavelengths. The interference actually appears as a pattern of concentric bright and dark rings called as fringes. The bright regions correspond to regions of constructive interference and the dark regions are as destructive interference. One standard use of Michelson apparatus is to measure the wavelength of the incident light. And now here is the question. One part is bright region corresponds to region of constructive and the dark region corresponds to destructive interference. One of the mirrors is moved closer or further away while observing the fringe pattern. As the length of one arm changes, the fringes all move together either in towards the center or out away from the center. When the pattern moves out by an amount such that each ring lies where the next one out used to be, the pattern is said to have moved by one fringe. Suppose that the pattern moves by n fringes while you move the mirror by a distance 1. Then the wavelength of light is given by lambda equal to twice L upon n. The yellow light from a sodium discharge tube is usually used for this experiment. Yellow light from the sodium lamp is dominated by Fraunhofer's D lines, two roughly equally intense closely spaced yellow lines which you observed in the previous lab. Since the wavelength is different, the interference pattern produced by each of these two lines do not necessarily occur at the same mirror setting. When you move away from the equal arm position, the fringes will appear to alternately fade out and reappear as a result of interference between the two lines. The condition for constructive interference for both wavelengths lambda 1 and lambda 2. Michelson Morley experiment was a scientific experiment to find the presence and properties of a substance called ether, a substance believed to fill empty space. Michelson and Morley created this experiment to try and prove the theory that ether exists. They did this with a device called as an interferometer. Now, what is the conclusion of this experiment? Any slight change in the spent time would then be observed as a shift in the positions of the interference fringes. The negative result led Michelson to the conclusion that there is no measurable ether shift. Now there are two postulates of special theory of relativity. First, relative postulate, as laws of physics are the same for observers in all inertial reference frames. Second one, speed of light postulate. Speed of light in vacuum has the same value c in all directions and in all inertial reference frames.